Hello everyone, today we are going to solve the experiment number 8 of our DDCO LAB assignment, that is design Verilog program for implementing various types of flip-flops such as SR flip-flop, JK flip-flop and D flip-flop. So first start with SR flip-flop. This is the circuit diagram of SR flip-flop. Here S and R are the inputs, CLK is the clock and QN and QN bar are the outputs. So this is the truth table of SR flip-flop. If the clock value is 0, S and R don't care and QN place is QN. S and R value are 0, 0, then QN plus value is QN. Know that clock time is 1 and 1 here. If we take 0 and 0, 0, 0, 0 and 1 is 1, 1 and 0 is also 1. So 1 and 1 gives the value Qn. So here Qn will come. So now let's try this case here 0 and 1. So it will remain as 0 and it will become 1. 1 and 1 gives 1 and 1 gives rise to 0. If 0 comes in one NAND gate, irrespective of another NAND gate, the output will be 1. So in QN bar, the output will come 1. This one will pass into this NAND gate. Here 1 and 1 gives rise to 0. So QN value in this case is 0. So here we say that QN value is 0. So by the same way, this case is same like as did, but this case when we take 1 and 1, obviously know that 1 and 1 gives rise to 0. Here also 1 and 1 gives rise to 0. 0 and 0 comes here. 0 and 0 gives rise to 1 and 1. So we know that Qn and Qn bar value should not be same. They should be different. So here Qn and Qn bar value is same. So it comes as invalid. Here this is the program for SR flip-flop. So first of all, here it begins with module. SR is the program name for this program. Here S and R are the inputs, Q and QB are the outputs. Again CLK, clock and reset are the inputs. So here we have declared inputs. Inputs are SR, clock and reset. Outputs are Q and QB. REG of Q, QB. Always at POSET of POSET CLK. Begin if RST, that is reset of Q, is less than or equal to 0, else begin. We have taken cases, that is S, R. So next step here we can consider that this is S and this is R. See, by the same way all the step will conclude. This is S, this is R, this is S, this is R, this is S, this is R. If S and R are 0, then Q value will be Q. If S value is 0 and R value is 1, then Q value will be 0. This will return according to the truth table we have written first. Here we can see that when S and R are 0, QN is there. When S is 0 and R is 1, 0 will come. When S is 1 and R is 0, Q is equal to 1. Here we can observe that S is 1 and R is 0, Q is 1. If S is 1 and R is 1, the Q will be invalid. Q will be invalid. So here we can observe that if S is 1 and R is 1, Q will be invalid. Then end case, then this begin will end here. Next assign QB is not equal to Q and end module. So next after SR flip-flop we are going to study JK flip-flop. Here this is the circuit diagram of JK flip-flop. J, K and clock are the input values and QN and QN bar are the output values. So the main purpose of using JK flip-flop is in SR flip-flop we got one output as invalid. So to solve that issue or that problem we are using JK flip-flop. This is the truth table of JK flip-flop. If J and K are 0, 0, so we can consider J is 0 and K 0. We know that in AND gate if one input is 0, then irrespective of another input the output will be 1, 1. So the output value will come as Q. In SR flip-flop also we have observed that the output of 0, when you give input 0 and 0, the output will be Q. So by the same way, other cases are going to work. So the main purpose of using JK flip-flop is to get that invalid input which we are not getting in SR flip-flop. So the main purpose of using JK flip-flop is, in SR flip-flop we are getting one input as invalid. So to solve that problem we are using JK flip-flop. So here we have started with module JKFF. Here JKFF is the module name or that program name, and we have given inputs here as J, K, clock and reset, that is J, K, CLK, RST, and output as Q and QB. Here we have declared input here. Inputs are J, K, CLK and RST, and output are Q, QB. And then according to syntax we have written registered of Q, QB. Then next, always at post edge of clock. Next we have begin if RST of Q is less than or equal to 0, else begin. We have used case, that is JK. Then we have used some of statements here. 0, 0, 2 0 are there. In this, 1 0 belongs to J and one other 0 belongs to K. In the same case, in the same step, next step, we have 0 1 is there. Here 0 belongs to J and K, 1 belongs to K. Here 1 belongs to J and 0 belongs to K. Here 1 belongs to J and K belongs to 1 belongs to K. So in first statement we have used if J and K are 0 0, then Q value must be Q. If J, in the second statement we have used, if J value is 0 and K value is 1, the Q value should be 0. This is as same as written as we have seen in the truth table. Here we can see that if J and K have 0 0, then the Qn plus 1 is Q. If J is 0 and K is 1, Qn plus 1 is 0. If J is 1 and K is 0, then Qn plus 1 is 1. If J is 1 and K is 1, Q bar will come. So by the same way, here we have also written if J is 0 and K is 1, Q will give 0. If J is 1 and Q is 0, if J is 1 and K is 0, Q will give 1. If J is 1 and K is 1, then Q is equal to not Q. That is, not Q means Q bar. So next, end case. The case has been ended here. Next, begin has been ended here. Next, assign QB is not equal to Q. Then end module. So this is the program for JK flip-flop. So next is D flip-flop. This is the circuit diagram of D flip-flop. Here D is present, clock is present, and Q and bar are the output. This is the truth table of D flip-flop. Assume that if clock has 1 1, if the D value is 0, then the Qn plus value here is 0. If the D value is 1, then the Qn plus 1 value will come as 1. Therefore, we can write this D flip-flop equation as Qn plus 1 is equal to D. This means what is the input D value? That is the output value of this. Like this, D flip-flop works. Here is the program for D flip-flop. Here we have named this program as DIFF. Here inputs are D, CLQ and RST, D, clock and reset. Here and outputs are QB and Q. We have declared inputs here. Inputs are D, clock and reset, and outputs are Q and QB. Then register Q, QB, always at post edge of CLK, begin if RST of Q less than or equal to Q, else begin. We have taken case of D. If D is equal to 0, then Q must be equal to 0. If D is equal, then Q must be equal to 1. We can see truth table here. If D is 0, the Qn plus value is 0. If D is 1, the Qn plus value is 1. So here we have declared the same way. If D is 0, then qn plus value is 0. If d is 1, then qn plus value is 1. Then this case will be ended here and this begin will be ended here. Assign qb is not equal to q in end module. So this is the program for d flip flop. So these are the some of the example. If we take JK flip flop, here they have taken J value 0 and K value 0 and they have set the clock value 0. Then we can see that Q and QB value is don't care. We have solved this already by writing truth table. So by the same way S of flip flop, here they given S value 0 and R value 0 and clock value 0. Then the Q value and QB value are also don't care. In also same way D flip flop, if they in this they are given d value 0 and clock value is 0, they have get output as q and qb as don't care. So this is already solved by us by solving truth table. Thank you.